Okay, so you guys are going to hear a lot about AI today. So I'm going to try and not talk about AI. That's a good news. But they're still not going to sponsor me unless I say something about AI. So there's AI in here. All right, the bad news is I'm going to try and cram 76 slides down your throats in about half an hour. So let's give it a shot and see how well you guys do afterwards. Now, if you're dizzy and you need another bagel or coffee afterwards, then I did my job. All right, so let's get going here. So I'm going to talk about serverless and then its relationship with AI and all that kind of stuff, just because it's very interesting. And the reason why genAI agents and things like that are it's kind of grayed out is because you can do serverless without anything AI. It could be just regular web apps or mobile backends, so you're not limited, right? You're just adding on to what it can do, what can't do. All right. Okay, so they already. I don't even need to talk about myself since they already did it, but Jeff is correct. I'm a software developer, but I also have been teaching for longer than I've been an engineer. I've also written a couple of things about Python, just because when I learned Python, there were only 2 books on the market, and neither of them met my needs, and I just was impatient. I couldn't wait anymore, and I just wrote my own. I don't, no, actually there may be a few videos here, but anytime you see like a blue box, like what you see on screen, that means I made some kind of video content on it, but there's not gonna be a lot. And I don't think my laser's gonna work on the screen, so maybe up there. Okay, so I am an AI TPM at Red Hat. So I'm actually focused on open source AI projects, especially in use with GCP projects. As well as Google tools and things like that, because I was at Google for like 13 plus years, so I have a lot of Google APIs in my head, and so this talk came from the work that I did when I was on the serverless team. All right, so before we get to talking about that, when I say I'm from Red Hat, people think, oh, Red Hat, isn't that a Linux company? So now I have to say something about Red Hat, because sometimes they also sponsor me, especially since they're my employer. So many years ago, everybody remember Linux? It's free and open source, right? And then large companies like, oh, we don't take anything free seriously. If you're not, CTOs are like, if you're not having me write a 5, 6, 7-digit check, I'm not gonna take you seriously. So guess what Red Hat did? They took the free open source Linux and they wrapped it with extra testing, compliance, tech support, and all that kind of stuff, charging a lot of money. That's how I get my salary. And so basically they built an enterprise version of the open source software. So fast forward to today, in the world of AI, same things going on. All of our customers are like, oh, we're supposed to be doing something with AI now, what do we do? Red Hat's following the same model. We take all the well-known open source AI communities and we wrap that into enterprise versions. So that's kind of like our line of business now, and Red Hat is growing pretty rapidly in the AI space. We've actually, we got acquired, I don't know if anybody knows, but we got acquired by IBM about 7 years ago. And now we're actually stealing their AI people. So we have a large and growing AI team, and I'm part of that. Okay, so the reason why I'm saying that is, again, these are some of the key open source projects. If you haven't run across like VLLM yet, you will, because if your company is doing any kind of inference serving, you're probably going to be using VLLM under the covers. And it's open source, and what a lot of people don't know is that most of the contributions actually come from Red Hat. So even, and for example, Llama Stack was started by Meta, but we are also a large contributor to Llama Stack. And then LLMD, it was a joint effort between Red Hat, Google, and NVIDIA, and a couple of other companies on basically scaling out and making a distributed version of VLLM. So all these big open source projects are part of the ecosystem, even though they don't have any kind of Red Hat branding, because that's what we do. We take open source stuff and we basically build enterprise versions of it. So here's VLLM. Again, if you're not familiar with it, you can run any open model on top of it, and you can run it on top of any hardware, as well as on-prem, in the cloud, on the edge, and things like that. So that's VLLM. LLMD spreads that out even further. So if you have a whole bunch of VLLMs running, and now you want a distributed version running on Kubernetes, that's LLMD. And then Llama Stack basically is an API surface level. So whatever you're building with AI, you could probably have one common API interface so that you can swap everything out in the back. So you can have different evals, you can have different telemetry, you can have different vector DBs, and all of it, you can keep your code the same because it gives you one common API surface. So anyway, so that's that. And then, of course, these things turn into enterprise products. So yes, there's an enterprise version of VLLM in that, and then there's an enterprise version of the other two in that. So Red Hat's just continuing to do what we did with Linux, but now with AI. All right, but this talk is, all right, so, and then the last thing is there's a large ecosystem. Google Cloud's in there as well too. So we're kind of like everywhere. And then on top of that, if you guys want to use open models because you don't trust the large proprietary ones, we basically provide validated versions of the open models, and we also have like specially compressed versions that are optimized for speed, using fewer resources, responding in a faster amount of time. So that's on Hugging Face, so check that out as well too. But this talk is not about Red Hat. I just wanted to give you an idea, because when people come to me afterwards and they tell me, I thought Red Hat was a Linux company. And so I just want to show you that we're not anymore. All right, so why are you here? Mostly talking about app modernization and serverless. You know, you're always trying to containerize your apps, get them on VMs, and then eventually move to the cloud. So Google can give you lots of VMs and big disks, but why should you consider serverless? And then just to basically get you up to date with what's going on, so that you realize you don't always have to have a VM, okay? So that's the main idea. So in between the intro and the summary, quick intro to Google Cloud, talk about the serverless platforms, give you some inspiration, and then we're gonna wrap up. Okay, so really quick review just to get everybody on the same page, because people come with different backgrounds, different levels, so I'm just gonna start all the way back at the beginning with cloud computing. So what do you need to know about cloud computing that you don't already know? So cloud computing is basically what? I think somebody already said it. You're using somebody else's computer, so you don't have to buy it, because guess what? If you're buying it, it's obsolete by the time it arrives at your shipping dock. All right, you don't want to have to like maintain that by yourself as a company all the time, right? So you're going to outsource your hardware, you're going to outsource your storage, you're going to outsource your applications, and probably the most well-known one is email, because when the internet came around in like the 1990s, you know, I don't think you wanted to give grandma SMTP, you know, a server on her desk and things like that, right? So there's IMAP, there was POP, so that we don't have to have a mail server running on our computers 24/7. So I've outsourced my email service to, you know, Yahoo with Yahoo Mail, or Google with Gmail, you know, or Microsoft with Hotmail. We are choosing to outsource our email service to a cloud vendor, all right? Why do I bring up email? Because that's part of a class of apps known as SaaS, all right? So anytime you have to go online or pull up a mobile app and log into something, that is a SaaS app. That's an application running in the cloud, because you've outsourced your email service, or you outsourced your office productivity tools and things like that, all right? So that's outsourcing of applications. You can also outsource hardware. So this is, everybody knows these are VMs, right? With a virtual machine, I don't have to go and buy something. I can rent an EC2 instance from AWS or Compute Engine from Google. I can get big disk as well too. So I'm outsourcing hardware. That's infrastructure as a service. And then a happy medium is, well, you know, the thing is, in order for me to get an app running on a VM, I have to also install the operating system, a database, a web server, all these things. What if I'm just an app writer and I don't want to worry about that stuff? I just want to upload some code and have it run. So that's what platform as a service is, and that's where most of the focus of today's session comes in. Okay, so yeah, and then sometimes, you know, because you're in a large ecosystem, what happens is there's a lot of gray area in between. So in between infrastructure and PaaS, we have things that are more than hardware, okay, but they're not quite a platform you can upload code to and run, right? So you're going to find all of your AI services here, your databases, data processing, data analytics. You're going to find networking stuff here as well too. All right, so all of those things are here in this gray area. Some people call it data as a service, but it's more than that, because like I said, it includes AI, it includes containers and things like that. In between platform as a service and SaaS, there's what there's no real term for it, I'm just making it up. I call it restricted PaaS systems. All right, so these are like PaaS, except the one big difference is that unlike their cousins, their pure PaaS, these are tied to data that live at the SaaS level. Okay, so you probably wouldn't use either of these systems unless you had data that lives up there. So Google Apps Script generally requires you to having some kind of workspace data. If you're using Salesforce platform, you should have some kind of Salesforce data. Otherwise, why wouldn't you use something more general purpose like what's in the middle? Okay, so that's what I call restricted PaaS. All right, so the interesting way of looking at it is turning it sideways, like what are you responsible for? All right, so you're responsible for the stuff in blue. All right, so with SaaS, I've outsourced the app. I don't care what the operating system is. I don't care what the hardware is. I just want to use the app, right? So that's SaaS. Platform as a service is where it's your code and the data that your applications use. So you're responsible for that, but you've outsourced everything else on down. Infrastructure as a service is where I've got the hardware. I'm renting the hardware, so that's everything in the gray. And then now I'm responsible for putting a Linux image on it or a Windows server if I need to have it. And then everything else all the way up to the top. And if you're on-prem, then it's all you. There's no cloud. All right, does this make sense to everybody? Okay, all right, so as long as everyone's on the same page, we can kind of like move on, okay? All right, so let's do that. Let's talk about cloud and workspace briefly. All right, so what is Google Cloud? That's a large organization that I used to work at. They produce two well-known product groups. One is GCP, which is all the cloud tools that you're familiar with, as well as Workspace, which is Gmail, Drive, Calendar, Doc Sheets, and Slides. The interesting thing about it is a lot of people think, oh my gosh, the left side is for developers, the right side is for end users. That's typically true, except what you may not know is behind all of the Workspace apps, there's probably an API as well, so that's for developers too. So everything is for developers. All right, and so if you're curious about how to code Gmail, Calendar, Doc Sheets, and Slides, I worked on that team for 6 years out of half of the time I was at Google, I actually worked on that team. So a lot of the sort of like the low-level hardcore videos probably have my face on it when I had more hair. Yeah, so people don't know that. So it's kind of like a public service announcement to let you know you guys can code it too. And the best part is those APIs are pretty much free. Unlike cloud, okay? So you can always just play around with it and just automate a lot of stuff that you shouldn't have to do with Workspace stuff. Okay, so where does GCP and Workspace fit into our overall cloud computing structure that I showed you earlier? Again, anything generally that's SaaS flavored is going to be Workspace, and then anything below that is going to be GCP. So Google has the entire stack covered, okay? And then particularly, since we're talking about serverless, I usually am referring to the ones in the gold boxes. There's a lot of options, of course, but the other ones generally, you have to know something about VMs or instances and things like that. Whereas with the gold ones, the serverless ones, you don't have to think about it at all. Okay, all right, running your code on Google Serverless. All right, so again, I mentioned that there's virtual machines and big disk, right? Google gives you all kinds of VMs from the free E2 micro that everybody gets every month. Everybody gets a free E2 VM. It's a shared CPU. There's not a lot of disk, but hey, it's free, right? All the way up to a monster of a machine with 416 vCPUs, 12 terabytes of disk, and 12 terabytes of RAM and then up to 256 terabytes of disk, all right? So you can get a monster machine. That machine is pretty pricey. The last I checked, it was like, I don't know, like $85 an hour or something like that. And then you can run, any kind of like Linux or Windows server on it. So Google does, it's GCP as well as AWS, and all the cloud vendors give you this option, all right? So why should you consider serverless, all right? So what is it? Well, first, it's a lie, okay, or what I refer to as a pedagogically motivated misrepresentation, okay? The reason is because if you are an application developer or you're building solutions for your organization or your customers, you don't want to have to worry about, oh, now I have to be a DevOps person, I have to worry about operating systems, security patches, and all these kind of things, right? So serverless takes that burden away, right? So you don't have to think about servers, whether they're bare metal or virtual, okay? So why serverless? So we've been tracking this, or I've been tracking this, or analysts have been tracking it. I'm just stealing their thunder. They've been tracking it for years, and it's one of the fastest growing segments in cloud besides AI, of course. And based on looking at the numbers, it seems like the corporate spend in USD is like doubling every couple of years. All right, according to different analysts, so the numbers are a little bit different, but they all say the same thing. A lot of people just don't have time to manage infrastructure, so they're just going to go with serverless, all right? One other interesting thing is when you talk about technology, sometimes it's all about the edge cases where we do the 80-20, but we don't do any of the edge cases. Interestingly enough, serverless actually does do the corner cases. So if you go viral, a lot of serverless systems are auto-scaling. So, if you get more and more traffic, the system will automatically add new instances of your app to be available for your users. And then as the traffic dies down, it starts killing them off. And then the other edge is, what if I built something but no one came, right? Am I paying 24/7 for VMs in Kubernetes? Or am I not getting billed because my app isn't up, right? So that's the main idea. It can auto scale to 0. So if you actually don't have any traffic, you're not getting billed. So that's another good thing about serverless. So I wrote a blog post on it, I think maybe last year or the year before. So you can check that out. It talks about this kind of background, why serverless. Including why not serverless, actually. There's reasons why you shouldn't use it, and that's also covered in the post, and I don't have time to talk about that today. So anyway, so as far as serverless goes, where does that kind of fit in? The problem is, all of the things up here in the diagram are quote-unquote serverless, because if I'm using like cloud SQL, that is a database in the cloud, right? Isn't that also serverless? Because I don't have to think about it. The answer is yes, but usually people, when they say serverless, they really mean serverless compute. So it's just the middle thing, the middle group, all right? Okay, so let's talk about the OG App Engine. That's Serverless 1.0, the first generation product. This actually launched from Google back in 2008, if you can believe that. That's many, many, many years ago. And the reason why they invented this product was because they went around the world and they asked developers, what are the biggest challenges to getting your app global and scalable? And they said, all these things in brown boxes. I don't want to worry about operating systems. I don't want to worry about configuration, software patches, and all these things. Oh, can you also make it scale if I get more traffic? Oh, can you make it so that I'm only paying if people are using my app? Oh, can you make it available in different languages? Because, you know, I have Java and Python in my enterprise. I just don't have one. Give me a local dev server. Give me a free database. Give me free mem caching. Give me free task queues. Give me free storage. All apps need that. Why should I have to go and get it myself? Please give me all those things. And so that's what Google did, and that's why App Engine exists. So if you haven't seen it before, here's your basic Python minimally viable product. So this is world's smallest web app. You give it what language, what version, your source code, which is a basic web app, and then third-party packages, and you just type this command, gcloud app deploy, in about 60 seconds. Your app is available globally. And it can scale like crazy, okay? Because the first royal wedding, not the one that happened a couple years ago, but the first one, like in 2011, that was an App Engine app, and their traffic went nuts. I know this because I was on the team at the time, and I was afraid that I would be the one reporting the bad news if it went down. But when I don't know how many of you were alive back then, but when the KISS happened, it was getting about over 10,000 requests per second. Okay, their web app. So just thinking about it, that's a lot of traffic, right? And popular languages that are included, or originally the original 4 were Java, Python, PHP, and Go, and then they added JavaScript and Ruby, or Node and Ruby, like a decade later. Okay, so it's definitely the OG. So the second generation did launch in 2018 with the new languages. Yeah, and it's great. One problem with the second generation service is they removed all those things like the free database, the free mem cache, the free this and the free that, because everybody said, oh my gosh, it's vendor lock-in, because if you write an App Engine app with those services, you can't move it anywhere else. So they took them out so that your app could be more portable, but now you don't have access to those services, which kind of sucked. So 3 years later, they added them back in 2021, okay? So this is one of the few things that it can still do that Cloud Run can't, and I'll talk about Cloud Run in a moment. Okay. So anyway, so App Engine still lives, but Google is not encouraging people to use it because there are newer products, okay, that you should consider, and starting with Cloud Functions, and I'll talk about where Cloud Functions lives in a moment. But why did this one exist? Well, this one existed because maybe you don't have an entire app. Maybe you have something small. Maybe you have, microservices, something you don't need an entire stack to build. No LAMP stack, no mean stack. I just have a little bit of code. Maybe it's a backend for a mobile app. I want it to do something like store a row in a database. That's it. I don't want it to do anything else. I don't want to have an app.
Also, I want to have it fire off if something happens, like I got a message in PubSub, or I dropped the file in cloud storage, or I logged in with Firebase, or something like that. I want to have event-driven things, okay? So the bold stuff are things that Cloud Functions could do that App Engine cannot do. So the other thing that Cloud Functions can do is it can let you create the function, it can let you code it, it can let you deploy it, and you can also test it all in the browser. You don't need to have a command line, all right? And there's also 2 versions of Cloud Functions too. There's a Firebase version if you have a mobile app, then there's a regular version, but it has changed as well too. So I'll talk about the evolution of Cloud Functions here. By the way, one user said Cloud Functions was the fastest thing. I didn't know anything about Cloud Functions. I got started. I was able to write a one-line hello world and get it done and learn everything in 15 minutes. Everything else that he tried took a little longer. So this is one user's experience. It doesn't mean everyone's going to have this experience, but they found Cloud Functions to be the fastest to get started. All right, and so here's your MVP. This is the one-line hello world. The deploy line is a little bit longer because there's no config file. It's even easier, right? And then you, again, in under 60 seconds or 60 seconds or so, you can access it globally, okay? So here's this, okay, so then the second generation happened where it became more flexible, and they kind of built it on top of Cloud Run, which I will talk about in a moment. So what happened in August of 2024 is that the second generation of Cloud Functions got rolled under Cloud Run because they built it on top of Cloud Run. Well, we might as well just formalize this relationship between the 2 products. Fewer product offerings, so less user confusion, that's good. All right, and then functions get access to Cloud Run features. Again, Cloud Run's the next one I'm going to talk about, so that's coming. For example, GPUs. And then so you can use gcloud functions deploy or gcloud run deploy. It supports the old interface, all right? So you can learn more about that transition at the links down below, as well as comparing products. Okay, and then so the merged version, which is cloud run functions, again, very, very similar. Almost everything is identical, just a few things have changed. Okay, cool. Now, so what is Cloud Run? Cloud Run is Serverless 2.0. This is definitely the latest platform. And the reason why it's needed is because from the time that App Engine launched, containers have taken over, right, as the main shopping bag that you ship all your apps with. There's no restrictions like with App Engine and Cloud Functions. You have to use these languages that we tell you. But in a container, you can use any language you want. You can use C, right? So it doesn't have those restrictions, and so that's why containers became very, very popular, right? And then Docker's kind of like had taken over the world between 2010 and 2017, right? So they're very, very popular. They're very, very flexible. Serverless was not as flexible, okay? So the thing is, if I want to do serverless, do I support language XYZ? Or what if I want to use a binary? That's restricted from serverless, right, because of the security. But we can't be locked in. I don't want to have to, write everything using App Engine's API and be stuck there. Why do I have to choose between the flexibility that I get from containers versus the convenience I get from serverless, where I can just sit back and just like run a deploy command and just armchair DevOps it, right? I want the best of both worlds. And so that's why Google launched Cloud Run, because it is containers. You can use any language, any library, any binary. The only thing Google asks is that you leave an HTTP port open and your app has to be stateless. So don't bundle it with a database, right? Use a cloud-based database, because if you access one Cloud Run instance on your app on one instance, and then the next time you send traffic to your app, it goes to another instance, you're going to be in trouble if they have their own databases, right? So you want to have a cloud-based database that all of the instances can talk to. All right, so that's the one restriction that you have to change in your app. Okay, but then you build your container. You can use Docker if you're familiar with it. You don't have to. You can just use Cloud Build because it wraps Docker under the covers. It goes into the registry, and then you can deploy to Cloud Run. Everything is great. You can also do GitOps. You can do CD push deploy. So when you do a git commit and a git push, it'll automatically start kicking off the process of building a container and deploying it. You can also do CI with CD if you use a tool like GitHub Actions, where you can run, on a git commit, it'll start running the tests and stuff, and then you can deploy from there. Okay, so that's that. All right, let's see. So, okay, so your Hello World, very similar, one-liner, all the languages basically, but they only have demos for like 10 in the docs because they can't document everything. Here's an Express one if you're a Node person. That was fast API, by the way. And then when you deploy, Docker file, Docker ignore, but the best part is you don't have to have those. They're optional, okay? Or at least the Docker file is optional. Docker ignore you should always have, no matter what, because it has the concept of build packs where a lot of people, love the idea of containers, but I don't want to learn Docker. I don't want to maintain a Docker file. So that's what build packs is for. It basically analyzes your code and automatically builds a dynamic Docker file for you. And so you can see I have a Node app and a Python app, and the command line is the same, right? So that's the cool thing about Cloud Run. All right, and then there's a lot of new features. Of course, the most important one is that you can get GPUs now with Cloud Run, so you can do all your AI workloads. All right, last serverless runtime is AppScript. So this is basically something completely different. It is serverless, but it's completely different. So imagine I want to create, this is a one-line application, by the way. I want to talk to Google Sheets. I want to grab the sheet. I want to put something in cell A1, okay? And then here it is. Now that looks boring, right? But if you realize that you actually wrote code to make this happen instead of you sitting there and typing it in, that becomes more exciting, right? I made a couple of videos on AppScript, actually. All right, but that's not a real app. What if I want to do something real? Like, this is real data I have in a spreadsheet, right? It's an address. It's in cell A2. What can I do with this? Well, I'm going to blow up that app and make it a 400% increase. This is a 4-line application, all right? It happens to touch 3 different Google products. I'm going to connect to Google Sheets. I'm going to grab what's in cell A2. I'm going to tell Google Maps, hey, make me a map. And then I'm going to tell Gmail, hey, send this map to my friends so I can meet them at the Google office in New York for lunch or something like that, right? So that's more useful, but it's only 4 lines of code, right? By the way, it's addictive, so be careful. Once you start using AppScript, it's like drugs. You'll want to keep on coming back to it over and over again. So taking this, what can I do with this? Well, maybe I run a book club or a user group, or maybe I have a sales team that wants to visit our top 4 customers in New York, all right? And I want to send email reminders. I want to put something in Google Calendar so they can see when DevFest is. I want to send out email reminders automatically as the date gets closer, right? All these things can be done with AppScript. You start with those 4 lines, and then you can build out a real app behind that, okay? So that's AppScript. Those are the 4 serverless platforms available from Google. Well, now it's 3 because Cloud Functions got rolled into Cloud Run, so now it's Cloud Run Functions, so 3. All right, so what about AI? Because we have to talk about AI, otherwise I can't be here. All right, so last year I wrote this very basic genAI web app that uses the Gemini API. I don't think I have time to do a demo, but you can take a look at the blog post and the code. But all it does is ask you to upload a picture and for you to give a prompt to the LLM. So my prompt is just describe this image, and then it's supposed to tell me something about it, okay? Yeah, so I have it in Express, in Fast API, Flask, all right? So it's just a generic web app that uses the Gemini API, but that still counts, that's AI, right? So basically it's very boring looking because it's just a hello world, right? Upload the image, give a prompt to the LLM. I gave a default for describe this image, but you can change it if you want. And then you go and pick whatever image you have on your disk, and then now it's all set. I changed the prompt for this particular one. I said, where is this and what is it? You can't see the is it because the text field is cut off. And then it tells you, right? So that's basically how this app works. Now, that is completely not related to serverless, right? That's just a regular web app running on, Express, Fast API, or Flask on my desktop. on my laptop, all right? Not online. Probably the most important part, I should show some code. The most important part is taking the image, making a thumbnail out of it, so that's that chunk. And then the rest of it is all magic, right? The magic is, what's my model? What's the prompt? Where's my image? And then please call Gemini to give me a result, and then turn the markdown into HTML. Those are the most important parts, and then render the template. So this is actually the core part of it. It's a pretty short app. I think it's only it's less than 200 lines of code, so it's very, very small, okay? But guess what? If I add a few files, I can make it run on App Engine or on Cloud Run with no change of code, right? So you just have to outfit your app in a way that you can make this happen, but it's definitely possible, all right? And these are the files that are basically highlighted, all right? So I added a Docker ignore, I added a gcloud ignore to not upload certain files that are not necessary, like the README. Why should I build that into my container? The README is not gonna be executed, right? And then I have a Docker file if I want one, but if I don't want to do Docker, like I don't want to learn Docker, I don't want to manage a Docker file, all you need to do is upload a proc file, which basically has the instructions on how to start your app. That way, it will make a Docker file for you, and it will look at the proc file on how to start your app. Okay, that's it. You can run it on App Engine if you have an app.yaml, which is kind of like a Docker file or a proc file, and that's it. You can actually run it on both if you want, okay? Yeah, so what other things can you run on Cloud Run? So if you go and start learning how to build agents using the, Google's ADK or Agent Development Kit, guess what? You can write an agent, and then you can also deploy that to Cloud Run. They even have a page on how to do that. You can also run inference. So if you're hardcore and you just want to serve models using Cloud Run, you can do that too, because now you have GPUs, okay? And then, of course, there's also MCP. That's another thing you can run on Cloud Run, but I'm not going to talk about that. So you have to go to Isaac. Is Isaac's here? Okay. Isaac's giving a talk on how to run an MCP server on Cloud Run later today. Hopefully I didn't spoil the surprise or anything like that. But yeah, exactly. So yes, so I left out all my MCP slides on purpose. All right, let's wrap up. So what have we learned today? Oh, by the way, before we completely wrap up, when you're writing with serverless on serverless platforms that do auto scaling, okay, so it's not AppScript. So AppScript, you could tell, was very workspace focused, right? Its primary reason is not performance. It's basically functionality and connectivity, because instead of using APIs, you notice that I connected to Google Sheets, Gmail, and Google Maps just with an object call, right? So there was no API calls there. So that's another magical thing that AppScript provides. It provides a lot of magic, so it doesn't do auto scaling, okay? So we're talking about just the GCP stuff, so App Engine and Cloud Run. If you're writing again on those platforms, apps for those platforms, you have to remember that latency is very important, because it wants to auto scale for you. So your app has to respond as fast as possible, and Google recommends under 100 millisecond response. All right, so the faster you respond, the faster it will auto scale for you. But if you're slow, the autoscaler would deliberately throttle you because your app is too slow, right? So make sure it's fast. Also, for architecture, make sure you break up large, monolithic components into small microservices, because then things will work faster. Each one being, having low latency. All right, and so the more you uncouple stuff that have state, the better. Don't have a built-in database. Use a cloud-based database. Use PubSub, or Kafka, or some other kind of message queue that can handle large fan-in and fan-out and things like that, okay? All right, so which do you choose out of all these things? Most of the time, you're probably going to pick Cloud Run. Why? It's the most modern platform. It can do various types of AI and agentic workloads because it has GPUs. It really is the next generation of App Engine, all right? And now that they rolled in Cloud Functions, you can do the small stuff with it as well, too, all right? App Engine is still there. It's the OG, all right? Most likely you won't use it for new stuff, but it can still do things that Cloud Run cannot. Like, it comes with a built-in database, a built-in memcache, built-in edge caching, built-in this, built-in that, and its outbound network traffic is much cheaper. So those are some of the few things that App Engine can still do that that Cloud Run can't, but there's not that many more. All right, you really should be using Cloud Run most of the time. And then if you are writing something that you want to have tight integration with Workspace because you're automating the back office, or if you want to talk to other Google services or even external services with JDBC, you can talk to relational databases, or you can talk to external services with HTTP, which means you can also call the Gemini API from AppScript as well, then maybe that's the right serverless tool for you, okay? All right, that is it. So what is the cost? App Engine, Cloud Run, and Cloud Functions have a pretty generous free tier, all right? If you are a student or faculty member, you could actually give your students and your TAs and your researchers access to cloud credits. So look up this link if you're a faculty member. If you're a student, you have to pester your professors to do this, because Google doesn't give student credits unless you're participating in a hackathon, all right? Otherwise, you can only get credits through your profs, all right? I don't have time to talk about the free tier and the free trial, but most of the time, all serverless tools have this always free tier. I would avoid using the free trial until you actually know what you want to run with it. And especially as a student, don't do it because you need a credit card. But with the student grants and the professor grants, there's no credit card needed. So I recommend that until you graduate. Okay, summary. Cloud computing is everywhere. Really, you should think about serverless because you don't have to be a DevOps person. That's the big thing. You just focus on the solution you're trying to build and getting it to the world. Okay? And there's a whole bunch of links. And bring me to your company if you enjoy these tech talks. I'm happy to do this. I have a consulting business at home, and I do this on nights and weekends. And sometimes, if it's important enough, I'll take time off of work to help you out with your Google needs. So just reach out. Otherwise, here are some links. You should take a picture of this one. I will provide the slides to Jeff and the organizers here so you can get it. The slides here are from a previous version of the talk where I had less AI and more serverless. So in case you want that, I made a bunch of videos as well too. So anyway, so these are all the things that you need except for the slide deck for today's talk, which again, I will make available to the organizers. So you'll have access to that too. All right, but thank you very much.
Wes, being the consummate professional that he is, finished ahead of time. So we have a couple minutes for questions. If you'd like to ask a question, the way the mics work, internally there's a white button. You press that, the microphone will pick you up. So if you have a question, please use the audio enhancement.
By the way, if you ask a question, I may give you a cloud sticker. Boy, the hands went up pretty fast. All right, yes.
Hi, my first question is what tips could you give a person that really wants to work for Google?
Ooh, that's a non-product related question, but I will still answer. What happens if you really, 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 really want to work for Google?
Yeah, what tips could you give?
Yeah, you know what's really interesting is that, so I just spoke at the DevFest in Seattle a couple of weeks ago, and a Googler actually gave a talk called, "So you want to work for Google?" So if you find it, look up the DevFest Seattle talk, because I'm sure he has good advice because he's a current employee. I'm no longer a current employee. But in my experience, if you want to get a technical job, definitely review all of your data structures, your algorithms, do the leak coding things. But yeah, and then also the thing is, don't get discouraged if you get turned down. Keep on trying, because I got rejected 6 times beforehand, and I finally got my job offer from Google on my 8th try. The 7th one I'm still waiting for. So after I actually did get my job and I was working there, I was asking about what happened to the last one. And they said, unfortunately, at one point, they actually had laid off all of the recruiters. So they cut the recruiter, but they also cut my candidacy too, even though he said, "I have an interesting update on your candidacy, and we got you to hiring committee." But they didn't bother following up. They just cut the recruiters as well as the people that were candidates, which kind of sucked. So anyway, just keep on trying. Also, don't be flexible, because Google is such a large company. There are offices everywhere around the world. So you can, I don't know how hard it is to get a job at the Paris office, but some people are like, "I want to live in Paris," or whatever. "I want to live in Tokyo, I want to live in Zurich." Don't tie yourself down to a specific location. Look for the job and then see whether you're flexible enough to move to take that job. Also, last one, don't apply for just one job at Google. You can apply for up to 3 at one time. It's better to buy more lotto tickets than to have just one, right? And if the recruiter thinks you should be a candidate for other jobs, they can open up all the way up to 6 or 7. But that said, I had a friend that had 7 open, and she got turned down for all of them. So it's very easy to get turned down because they get 1 million resumes a year, and they can only hire 0.7%. Or 0.7 of 1%. So yeah, so it's pretty tough. So, but yeah, don't give up. All right, next question. Sure. Yes, sir.
So I just wanted to get your take on the whole Google serverless versus, say, Amazon serverless, and what's going on in that world. I kind of live in Google Cloud, and I'm just
Sure.
curious what your perspective is on what the other half is doing.
Yeah, you know what? I think all the cloud vendors have some kind of serverless. Some people had gotten the wrong impression that the only thing that was serverless was Lambda, and that's not quite true. Of course, Lambda is serverless, but that's just functions only, right? They didn't add App Runner or their other products until later. But I'll just say that the way they differ is, for example, with App Runner on AWS, you had to set up a lot more stuff. Like you had to take care of your DNS and all that stuff. Yes, you got your container up, but getting traffic to it was not as automated. I'm not sure about Azure as much, but yeah, they're all a little bit different. And so what I would encourage you to do is sort of like a try before you buy, see what you like, try them all, deploy a container to all of them and see which ones work better for your needs. And then also check the pricing as well too. Google aims to be slightly cheaper. It's better technology maybe, but the marketing is not as good, right? So yeah, that's just some advice that I have.
Did you pull a
Great.
sticker?
Pardon?
Did you pull a sticker?
I did.
Oh, you did?
Yeah, I was so fast, didn't even see it.
Yeah, I know.
All right, next question. Sir, go ahead.
Can you hear me?
Yeah.
Okay.
Oh, can somebody pass the sticker back? I can't.
I'm a student from St. Cloud State. I'm a student from St. Cloud State, and I'm majoring in software engineering.
Yeah.
And I have a question that I, as a student, how do I really get started on things? Like, I'm getting to learn a lot of, about these tools, but how would I get started? Like, what's the starting point of using them?
You're learning a lot, but you haven't been able to get started on using them. This is actually, I forgot one thing. I lost a lot of my thunder because I didn't show the progress bars. I'll talk about the progress bars in a moment because you're probably wondering, what the heck is the progress bars thing on the lower right-hand corner? So I apologize, but there, okay. You were supposed to see progress bars that show like, what is my progress during this talk? Like how much longer is this dude gonna talk for? But this is also something you can do with Google APIs because neither PowerPoint nor Google Slides has progress bars, so you can code it. So my colleague built this and I made a video with him. It's pretty fun, but if you just scroll back to any of these other slides, you can see that there's a progress bar. So I apologize for not showing you guys that live. I thought I turned it back on last night, but I didn't. So again, I apologize. So back to the question about getting started. The way you get started is most, if not all, Google developer products have some kind of quick start. And so that is the fastest way to actually get started. Its purpose is to actually answer your question. You're supposed to be able to get started with any Google technology within 5 minutes, and that's what a quick start does. So what you really should do is you should try out all the ones that you think you're interested in because it won't take too long to get started with it. And the other thing is, in today's day and age with AI, it's more challenging to get a job in software if you don't already have familiarity with AI. So make AI part of your normal workflow. Vibe coding is a very common thing, but the thing about it is they're like a very junior software engineer, a very enthusiastic junior software engineer, so it doesn't always get it right the first time, but it's getting better and better. So you should actually roll AI as part of your workflow. It's to augment what you do. The problem is we can't go 100% vibe coding because if nobody knows how to do software engineering, then we never will really know whether or not the vibe code that's generated by an LLM is correct. So you still have to put in all the time and hours to learn how to be a good software engineer. So in the future, a software engineer is going to be half developer and half product manager because you're mostly specifying to the LLM how to build the thing, and then when it outputs the vibe code, you're fixing it and perfecting it. So that I feel is the next generation of software engineer, as well as answering your question. So I hope that helps. Sure. Any other questions? Yes, ma'am. Yes, it is. The question was, how did you program those progress bars? It is AppScript. It is a Google Slides add-on, and you'll see that if you go to the blog post and check out the video and the GitHub repo. All right, and then I'll be around for most of the day, so if you have any other questions, feel free to come and find me. Happy to chat with you. I like to meet people from from all over the world, actually. I'm based in Silicon Valley. I never realized what cold was until I got here. The coldest it gets for me at night is like 29, and that was warm. That's even hotter than today's high. So anyway, thanks for having me.
And it's 30 degrees more.